Hello everybody, this is Gigi. In this video, we will be talking about the equation of a circle. Okay, so let's define what a circle is. A circle is a set of points that are equal distance from the center. So the center is a fixed point, okay? A fixed point, for example, there. The equal distance, say, that distance. Now the circle is a set of points. If you just keep staying the same distance at that same distance from that center, that will make a circle. Okay, and that equal distance is what we call the radius, right? The radius. So no matter which point you end up at, that to the center is always the radius. All right. Now, in this video, we will learn what the equation of a circle is. Okay, so let's just start small. For example, we are locating this center right here, and the center is at 4, 1. That's that point right there. And suppose that the distance is 3 units, meaning the radius is 3 units. Let's draw that set of points. Here is 1 point, 3 units to the right, 3 units up, that give me another point, 3 units to the left, that give me another point, and 3 units down, that give me another point. And then you'll see the set of all of these points here will make the circle. Right? Set of all of these points here will make a circle. Okay, now each one of these points has an x-coordinate and a y-coordinate. Okay, so the next question on your note packet is asking you to go ahead and use the Pythagorean Theorem to find the equation that model the set of all of those points. So the set of all of those points, let me just pick one so we can reference it. I'm just going to pick that 1 point right there. And that blue point on the graph, I'm going to call that x comma y, right? A point on the graph has an x value and a y value. And it's an arbitrary point, so we can just call it xy. The distance from the center to that point, as we know, is the radius. In this case, the radius is 3. Use the Pythagorean Theorem. Now, Pythagorean Theorem comes from a right triangle. Pythagoras said, if you have a right triangle, then leg 1 square plus leg 2 square is going to equal to the hypotenuse square. So leg 1 square plus leg 2 square is equal to the hypotenuse square. Or you might have heard it as a square plus b squared equals c squared. Okay. So do you see a right triangle within our picture here, where 3 is your hypotenuse? Yeah, if I drop this down and I say this distance, right? So there's the red leg, the blue leg. Let's use a different color than blue, because blue is your hypotenuse. So let's use purple. The purple leg, red leg, and the blue hypotenuse. Okay? Now let's go find the distance. So for the red leg, this right there is x, because that's how you get to that point xy. Go out x unit, up y unit. Matter of fact, this is y. Right? And that's how you get to the point xy. All right, now this right here is 4. So this distance, the red distance, is x minus 4. The distance from x to 4 is x minus 4. Absolute value, if we are afraid it's going to be negative. But since we are going to square it anyways, it really doesn't matter. We don't need the absolute value. We can just write parentheses. Now the purple distance, this is 1, and then this is y. So that purple distance is the distance between here and here. That denotes y minus 1 square. So what you have here is x minus 2 square plus y minus 1 square equals the hypotenuse square, which is 3 square. So really, the equation of this red circle here, with the circle center at 4, 1, with radius 3, the equation that will model that is x minus 2 square plus y minus 1 square equals 9, which is 3 square. Does that always work? Let's go take a look. Suppose then you have any arbitrary center, HK. Okay, any arbitrary center, HK. And if you draw a circle with radius r, and xy is the point on it, do you see a right triangle? There's the horizontal distance, and here is the vertical distance, and that makes a right angle right there. Okay, now let's take a look at the horizontal distance. This right here is x. This right here is h, because that's how you get to those points, right? So the red distance is x minus h, absolute value, in case it's negative. The purple distance, well, this right here is the y value, and this right here is the k value. So this purple distance, the distance from k to y, which is y minus k, and I say absolute value in case it is negative. Pythagoras would say, within that triangle, that right triangle, as a matter of fact, leg 1 square plus leg 2 square equals hypotenuse square. Leg 1 is x minus h square plus leg 2 square, which is the purple part, y minus k square is equal to the hypotenuse square, and the hypotenuse is the radius square. So again, given any circle with center of HK with radius r, the equation is x minus h square plus y minus k square equals r square. Why does it work? Pythagoras will tell you why it works. He said a squared plus b squared equals c squared, right? That's where that comes from. All right, now let's do some example. Remember that x minus h squared plus y minus k squared equals radius squared. All right, here we go. You have the point 5, negative 3, 5, negative 1, negative 2, negative 3. Let's call that point A, 5, negative 3. And let's call this point B, just so we have a reference. 1, negative 1, 11. Negative 1 up 11. Oh no, goes out of your chart. That's okay. It's right here. Okay, that's point B. And point B is negative 1, 11. If you connect those points, that is your diameter. In order to find the equation of a circle, what do I need? A center and a radius. So where is the center? If that is your diameter, somewhere in between. And when I say somewhere in between, I am talking about the midpoint between A and B. The midpoint is the point in the middle. So it's the average of the x, the average of the y. And how do we find average? Add and divide it by however many. How many do we have here? 2 points. So add and divide by 2. 5 plus a negative 1 divided by 2 is your x value of the midpoint. Negative 3 plus 11 divided by 2 is the y value of your midpoint. And the midpoint is your center. All right? So where's my center? Do the computation here. 5 minus 1 is 4 divided by 2 is 2. Negative 3 plus 11 is 8 divided by 2 is 4. My center is at 2, 4. 1, 2, 1, 2, 3, 4. Right there. There's my center. 2, 4. So far, we would say the equation of the circle is x minus 2 squared plus, right, x minus 8 squared plus y minus k squared, y minus 4 squared equals radius squared. I need to go and find out what this radius is. How do I find out what that radius is? Again, our famous mathematician Pythagoras. Can't spell today. Pythagoras would say, in a right triangle, which we do have, right triangle, and here's your radius. A squared plus b squared equals c squared now. So this is 3, because that's the distance from 2 to 5. The distance from 4 to negative 3 is 4 minus a negative 3, which is 7. Or you can just count, and you can see that that's 7. So 7 squared plus 3 squared equals radius squared. Now, 7 squared is 49, 3 squared is 9, equals radius squared. So radius squared is 58. Where does that go? Right there. 58. So there is the equation of the circle. Now, if you had to, you can say, I'm going to square root both sides, so the radius is square root of 58. Which is 7 point something, because square root of 49 is 7, and square root of 64 is 8, right? So it's 7 point something. But the question was asking for the equation. So there's your answer. X minus 2 squared plus y minus 4 squared equals 58.